Hello everyone, welcome to our channel CodeChef. This is Kusmulata Bhatt and today we are going to solve the problem bubble swap count, which is of Cakewalk difficulty level and it requires sorting and understanding of index of arrays as the prerequisites. So let's understand the problem statement first. We need to shuffle a series of number from 1 to t inclusive. That is, we are given with a series of number in which there are numbers from 1 to t exactly, like if t value is 5 then it is going to contain 1 2 3 4 5. The numbers are in ascending order. You have to shuffle them using bubble sort algorithm. Now we have to shuffle this series using the bubble sort algorithm, that is swap every time a number is greater than another in the given list in the input. That is, if we have the situation like this in which we are saying that 5 is greater than 4, then we have to swap these values. Print the count of swaps done while you run the algorithm to shuffle them. That is, we have to report all the counts of swaps we are doing while applying the bubble sort on our list. So let's see the algorithm for bubble sort. So in the bubble sort, here we have taken length of a minus 1 as n and then we are applying the bubble sort, and then we have a loop which is running from 0 to n inclusive, and then we have another loop which is running from 0 to n minus 1, and then in this we are comparing the two adjacent neighbors, and if the former one is greater than the later one then we are simply swapping the two values. Now here we have to report the total number of swappings that are happening in this problem at this point. So this question is straightforward. We have an A array which we need to sort using bubble sort algorithm. And we need to simply return the number of swaps which are taking place while applying this bubble sort algorithm. So what we have to do, we have to simply implement this algorithm in the terms of code. Now what will be the space complexity and time complexity per test case? So time complexity for this implementation is simply O of n square, because here we are running two loops, one from j0 to n and another from 0 to n minus 1. Then it will simply result into n minus 1 iterations of loop. So we can say here we have the time complexity of O of n square. Now the space complexity per test case is going to be O of n because we have an array of n integers for every test case. So let's see the input description for the problem. Input will start with an integer n on new line representing the number of test cases, and then in each test case we are going to have number t on a new line which will represent the total number of counts of numbers, and then for every test case we have t integers which is representing the final shuffled series of numbers. And for the output here, for each test case, we have to print the desired output each on a new line. So let's have a look on the C++ implementation of code. So here we are taking the input of test cases, and then for every test case, we are taking the size of the list n, and then we are taking the input of the list elements. Then we are initializing the number of swaps as 0, and we are taking the n as the size of the length of our list minus 1, and then we are simply converting the algorithm which is given to us in the form of the code. So as per that, we are running a j loop from 0 to n inclusive where n is the size of list minus 1, and then we are running another loop from I equal to 0 to n minus 1, and if we are saying that a of I is greater than a of I plus 1, then we are swapping a of I and a of I plus 1, making sure that every time we are incrementing our counter variable which is keeping track of the number of swaps that has been done up to this point. Now let's have a look on the Python implementation. So here we are running the loop for every test case. Here we are taking the input of test case directly, and then we are running a loop in it, and then we are taking the input of the size of list, and then we are taking the input of list, and then we are incrementing the variable for keeping track of the number of swaps, and we are initializing it with 0 because we have not done any swap yet. Now we are having another variable small n initialized as length of a minus 1. Then we are converting the given algo to the Python code. We are having a loop which is running from 0 to n inclusive, and then another loop which is running from 0 to n minus 1 inclusive. And if we are seeing that a of j is greater than a of j plus 1, then we are simply swapping the two elements and we are incrementing our counter. And then what we are doing, we are simply printing the number of swaps which has been done in the problem yet. So the common mistakes we can do here, we can mess up with the variables. Like in the algo, we were providing the first loop as j, but here I have taken the first loop variable as I, and similarly in the second loop they have taken I, but here I have taken j. But for this I am making sure that I am using a of j greater than a of j plus 1 here. So we have to keep this in mind that we are converting the algorithm to the code consciously and we are using the right set of variables. So that's it for the video guys. Please subscribe the channel and stay tuned for the more.